Hi everyone, in this video on my learning shader series, I'm making a simple flag shader. In the last two videos, I made fragment shaders that were affecting the colors of an image. So I wanted to make something with the vertex function now. This allows to affect the geometry, so it should be fun. Without further ado, let's get started. So, as I said, I'm going to use a vertex shader to animate our flag. I initially started using a simple sprite with the flag texture, but I couldn't understand why the shader was not working as I intended. So, let me show you what is happening. And don't worry, we're coming back to the shader code in just a minute. I've got my shader all done here, and I'm expecting to see a wave-like effect. And this wave should change when using the frequency parameter. We can actually see some changes, but the whole flag is moving like a solid piece. I probably should have researched Vertex shader a bit more before diving into this, because this is actually pretty obvious what's happening here. You see, a vertex shader can affect vertices, and how many vertices are in a sprite? You guessed it, only 4. And that's why my shader is not behaving as I expected, simply because there's not enough vertices to deform the image as I intended. Okay, so now that we know that, we have different ways to approach the problem. You could make a fragment shader that does the same thing, or maybe use a mesh 2D node. I decided to use a polygon 2D node. That way I can set up how many points I want. I quickly added a bunch of points to make sure the flag could deform. Alright, now we can create a new shader and start coding. So basically, what I want is to have a wave-like effect on my flag. And you know what mathematical function does that? Yes, the sine function, or the cosine, as you wish. The sine is very often used in shaders because it provides a nice wavy pattern that repeats forever. This is perfect to make our flag move. In the vertex function, we can move the vertices using the vertex output. So for example, if I put the result of the sine function with the uv.x parameter and plug it in the vertex.y output, well, we see nothing. This is because the result of the sine function is too small. So if I multiply by, let's say, 50, we can now see our function better. I'm going to create a uniform called amplitude, and I'm going to use this instead of the hard-coded 50. That way we can control the amplitude outside of the shader. Oh, and see how I'm using the uv.x inside the sine function to plug the result in the y component of the vertex. This is because I want the flag to move up and down depending on how far left or right we are on the image. But still, we get the idea that we are using a sine function, but this doesn't look very wavy. This is because uv is between 0 and 1, but this is a small range in the sine function with its period of 2 pi. One way to reduce the period, or said otherwise to see more waves, is to multiply our uv.x by a factor. Again, I'm creating a uniform called frequency, and I'm going to use this to multiply the uv.x. As you can see, if I increase the frequency, we see more waves. Cool, this is starting to look like a wavy flag, but it doesn't move. Fortunately, there's a handy thing we can use inside our shader, which is called time, which is the global time in seconds. Because this value is constantly changing, we can use that to make the result of our sine wave change. So, if I subtract this value to our uv.x inside the sine function, we now see our wave moving. And again, we can define another uniform called speed that when multiplied to the time will affect the speed of the time passing and thus the speed of our wave effect. Right now, we are very close to the final result. There's one last thing I want to tackle. See how all of the flag is moving right now. Usually, the flag is attached to a pole, so it won't really move where it's attached. In my case, I want the flag to be attached to its left. So what I can do is find a way to dampen the effect when we get closer to the left side. Fortunately, this is very easy to do using the uv.x coordinate. Remember that uv goes from 0 to 1, so if we multiply the result of our sine function by uv.x, the left side is completely still because uv.x is 0, and the right side is completely moving because uv.x is 1. And with that, we got a really nice moving flag. In my final shader, I added another another uniform to control the X frequency, and I basically duplicated the line we wrote, but to move the vertex.x this time. So for that, I'm using uv.y. I've done the same with the amplitude as I want it to be smaller. Also note that I'm using a cosine instead this time. Sine and cosine are basically the same function, but with a phase shift of pi divided by 2. So this will offset the effect on the x-axis and will feel much more natural. To finish, I've added one last uniform called inclination. This is used to incline the flag, which can happen if there's a lot of wind. I'm using this uniform by simply subtracting uv.y multiplied by the inclination to the vertex.x component. This way I can incline the flag left or right. I won't go over all the details, but it's pretty easy to move this shader to 3D as I've done here. Just remember to subdivide your mesh to have enough vertices to work with, just as we did in 2D. So here I'm using a plane with a subdivide of 30 for both width and depth. I'm basically using the same function with nearly the same parameters. I just need to change the axis. Just be careful when switching the axis though, you need to use the local axis of your mesh. So just click on the little cube here to use local space, that way you can see the orientation of your mesh in its local space. And with that, we got a nice little flag shader for both 2D and 3D. You can make it a bit more interesting by adding some noise to the values. That would make it a bit more realistic. If you want a very good looking and realistic 3D flag shader, check out the video from GDQuest. They use a noised texture based approach that is very interesting, and with what we've just seen, you should be able to understand pretty easily. I hope you liked this video and this cool effect. If you have suggestions on what to make next or how to make this shader better, please tell me in the comments below. Remember that I'm learning as I'm making these videos, so if I'm making mistakes or things could be better, please tell me, or better, make a pull request on GitHub. The shader is available on godot-shaders.com, and as always, the sources are available on my GitHub, link in the description. If you want to discuss this video, see what I'm working on, talk about game dev, or just hang out, join us on my Discord server. Just scan this QR code or use the link in the description. Thanks for watching, see you later, bye!